Hello guys, I'm Aljan H. Perer from BSECE 3C. So this is ECE 23 Performance Task 10. So this is all about TDM. So what is TDM? TDM is a time division multiplexing. It is a technique for transmitting two or more signals over the same telephone line, radio channel, or other medium. Each signal is sent as a series of pulses or packets, which are interleaved with those other signals or signals and transmitted as a continuous stream. So, next is the SONET. So, our topic for today is the SONET, which is also part of a TDM. So, what is a SONET? So, SONET stands for Synchronous Optical Network. So, SONET is a communication protocol developed by Bellcore. So, SONET is developed by Bellcore and it is used to transmit large amount of data over a relatively charged distances using an optical fiber. With SONET, multiple digital data streams are transferred at the same time over the optical fiber. So these are the key points for SONET, or the keywords that we need to in SONET. So SONET is developed by Bellcore. It is used in North America. Standardized by ANSI. So what is an ANSI? So ANSI is an American National Standard Institute, and it is also similar to STH. So what is STH? So STH is a synchronous digital hierarchy, which is used in Europe and Japan. So SONET is standardized by ANSI and it is similar to STH. And the key points is that it is also developed by Bellcore. And when we talk all about North America, and SONET is the best signals that they used. So why SONET is called a synchronous network? So SONET is a single clock primary reference clock, or PRC. It handles the timing of transmission of signals and equipments across the entire network. So SONET is called a synchronous network because it is a single clock and it handles the timing of transmissions of signals. SONET network elements. So we can see here the SONET network elements. The the four boxes which represents the input terminal. Then the input terminal goes to the STS mux, then goes to the regenerator. Then after the regenerator, go to the add or drop of mux. Then after the add or drop mux, then it is go to the regenerator. Then go to the STS mux or DMux. And after that, the four terminals here which represents the output of our network, the section, then the section, the line, and the path. So what is the section? So the section here is the used to connect the two neighboring devices. Then after the section, it is the line. So the line, it connects the two multiplexer, and the path represents the end-to-end part of our network. So we can see here the section in STS and mux and regenerator. You can see here the section, then here section. Then here represents the path from STS mux to add or drop mux. Then from add to drop mux to STS mux or DMux. You can see here the two lines, and the overall is called the path. So first, the STS mux or DMux. So first, what is STS? So STS is a synchronous transport signal. So STS MUX. So STS MUX multiplexes the input signal in the terminal. It multiplexes the signal by means of converting electrical to optical signal. Then, after the STS MUX, it goes to the regenerator. So what is the regenerator? So regenerator is a repeater that takes the optical that been multiplexes by the STS MUX and regenerate its signal by increasing the strength. Then after the regenerator, goes to the add or drop MUX. In the add or drop MUX, after that, you can add or drop your signals. Then after the add or drop MUX, we goes again to the regenerator, or same function as the previous regenerator. It is a repeater that takes the STS MUX or the add or drop MUX and will regenerate its signal by increasing its strength. Then after the regenerator, we go to the STS MUX. So in the STS MUX, or the STS demultiplexer, it demultiplexes the strength, and it is the reverse process of the STS multiplexer. So the STS multiplexer is from the electrical to optical, but now we are here in the STS demultiplexer. So STS demultiplexer is from the optical to electrical signal. It converts our signal from optical into electrical signal. Then it goes to the output terminal. And the section is the connects the two lines, the two neighboring devices. The STS MUX connects to the regenerator, and the regenerator to add or drop MUX. And from add to drop MUX, it connects again to the regenerator, and regenerator to STS MUX or DMUX. Then the line from the line connects the two multiplexer from STS MUX to add or drop MUX. Then from add to drop MUX, it connects to the STS demultiplexer. Then the path that represents our end-to-end signal from STS MUX to STS demultiplexer. Then from the input terminal, it goes to the output terminal here. So SONET layers. So you can see here the data link on the physical. So from the data link, you can see here the layers, the path layer, the line layer, and the section layer. Then the physical, or under the physical is the photonic layer. So SONET includes 4 functional layers. So these are the 4 functional layers of the SONET. Number 1 is the path layer. Number 2 is the line layer. Number 3 is the section layer. And number 4 is the photonic layer. So first, the path layer. It is responsible for the movement of signals from the optical source to its optical destination. Then 2, the STS MUX or DMUX provides the path layer functions. Then number 2, the line layer. It is responsible for the movement of signal across the physical line. Then number 2 of the line layer is the STS MUX or DMUX, and add or drop MUX provides the line layer functions. Then number 3 or the section layer, it is responsible for the movement of signal across the physical section. Each device of the network provides the section layer functions. The number 4 is the photonic layer. It corresponds to the physical layer of the SONET model. So it includes the physical specifications, optical fiber channel. Presence of light is equals to 1 and the absence of light is equals to 0. So what are the advantages of SONET? So these are the some advantages of the SONET or its summary. It transmits the data to large distances. So SONET transmit data to large distances, or it transmit data to a very long distances. Then It is low in electromagnetic interference. It is high in data rates, and it is large in bandwidth. So that's all, guys. Thank you.